In this section, we're going to practice what we learned in the last video and add a little bit more to it. So we have already done linear. And when your slope is greater than 0, it means it's a positive slope. So it's going to look like that. And when it's less than 0, it represents a negative slope. And it will look like this, where the skier goes down the mountain. In a quadratic form, remember, when A is positive, it opens up. And when A is below 0, it goes down like a frown. Okay, that creates that positive and that negative parabola. When I have an exponential where the absolute value of B is greater than 1, that is actually going to be a positive increase. That is called growth. And when it's between 0 and 1, remember it's got to be a fraction, it's going to represent a decay. Okay, so we have the negatives and the positives on all these. Let's go down here. Now, how would I know if these are linear, quadratic, or exponential? Well, remember, we said linear. When the exponent is to the first power, that's linear. So this guy's linear. This is exponential because I have 5 to the x power, so this is exponential growth. And you got to say growth because this number is greater than 0, greater than 1. Over here, it's quadratic because it's to the second degree, so quadratic. Here, this is exponential decay because my fraction is 1/4, so exponential decay. Now, this is in factored form, so it looks kind of like, oh, it's linear because I have x to the first degree. But remember, when you multiply these out and you FOIL it, or double distribution, it becomes x squared plus 5x minus 14, and this creates a quadratic. So that is a quadratic equation. Number 6 is linear because it's to the first degree. X is to the first degree. Over here, this is 3 over 2, which is greater than 1, 1 and 1/2. So this is exponential growth. Y equals 6 is linear. It's a 0 slope. It's still linear. This is a quadratic. It's to the second. Here, if I got y by itself, what would I have to do? I would have to multiply both sides by x, and then when I distribute, I would get x to the second power, making it quadratic. Here, this is 6, so it's going to be exponential growth. And this guy is linear, and it is in standard form. So that's what it looks like in an equation. And then, of course, in a graph, this would be exponential growth. This is a straight line. It's linear. 15 is quadratic. So I think from the graph, that's pretty easy to determine. So let's go look at this table of values here. Now, well, real quick, what's that one? 16. We haven't seen anything. That's cubic. We haven't talked about it. So we're going to put neither on this one, none of the above. And, of course, linear and exponential decay. All right, when you're looking from a table, remember, we're looking for the change in y. So here, I subtract 1, subtract 1, subtract 1, subtract 1. So, of course, it's linear. Over here, my change, I notice there's not a pattern if I multiply it or the constant's not the same. So if I go from negative 3 to 5, it's adding 8, it's adding 4, it's adding 0, it's adding, subtracting 4. And then here, of course, my change in 8 to 4 is subtracting 4, subtracting 4, subtracting 4. So the second common difference is making it quadratic. And of course here, multiply by 3, multiply by 3, multiply by 3, and multiply by 3, and that is what makes it exponential. So we already discussed that in the last one. So let's take a look. I'll just do 19 and 21 with you guys. So here you're subtracting 2, subtract 2, subtract 2, making it linear. I lied. Let's do a few more. Here, I'm going to go backwards, and I'm going to look that if I divide it by 3, divided by 3, divided by 3. So I can divide all these by 3, So therefore, it is going to be exponential. Okay, and it's a decay because I'm dividing. If I were multiplying, it would be exponential growth. All right, let's look at 21. So 21, what's my difference here? I'm going up by 30. I'm going up by 24, 34. And I'm going up 60, 70, 80, 90, 48. Okay, I think my math is correct. 38, not 48. 38. Okay, so now I go up by 4 and up by 4. So my second one is going to be the same. So that means it's going to be quadratic. My second change is the same. Okay, so that gives me a good visual for all three. I think you're probably pretty good on that, but let me know if you have questions.